All right. Morning, y'all. So let's see. So remember, we have our first quiz on Friday. So probably what we're going to do is, we have something we're going to cover, and then I'll stop like 10 or 15 minutes before the end of class for the quiz, and then the intention is that the quiz should take you, well under the amount of time that I'm going to leave. So hopefully, partly that's if you get time and a half on quizzes or that kind of thing, hopefully like that it should already accommodate how much time you need. If you feel like you're not getting enough time, definitely come talk to me and we can work that out. I don't really care how long it takes you. They're not really intended to be like a timed quiz, but going forward, it'll also be like, I'll leave a bunch of time so that maybe if there's you're taking a quiz and you're also retaking an old quiz, you might have time to do both, whatever. So that's the plan, and then but once you finish the quiz, then you can just leave. So that way you're not sitting there at the beginning of class waiting for everyone else to finish their quiz. If you turned in the homework, right, then you should have gotten it back. And if you, especially for these ones where it asks you to do it and then check yourself, right? You're kind of already getting feedback on it just from the computer, and so you may not have gotten anything on it from the TA other than great job. But if you did, that's fantastic. That means you are you should be ready to take the quiz. So hopefully it's just confirmation that you're doing what you should be doing. I think that's all. All right. Let's see. Yeah, the thing I tried, the recording from last time still did not have my screen, so I think I'm going to be able to do it today. I'm not going to use Teams to record it. So it should be recording. All right. Alrighty. So today we are going to learn about conditionals. So, right, this is one of the big 5 things that we talked about beginning of the semester, right? So we kind of in Python we know how to do we definitely know how to do math. Input output, sort of, in the sense that we can make a function that takes some inputs and gives an output. There's other things you might need by input and output, like having it print something out on the screen, or ask the user to type something, and we're going to learn about that as well later. And I don't know, maybe I forgot to say this on Friday, but all that stuff learning about Booleans, that's where that was going. Is Booleans are what we need to be able to have conditionals, because a conditional says, well, based on the answer to some question, I'm going to make a choice. And so, well, the answer to a question is going to be a Boolean, and then depending on whether it's true or false, we can make different choices and do different things. Okay, so you've all already seen conditionals on the Minecraft lab, but you had a pretty limited set of questions that you could ask, right? You could say if there's lava ahead, or I don't remember, there was a few different questions you could ask, but it was pretty limited. We're going to have a lot of different questions we can ask. Oops. So conditionals. So I'm just going to start by, I'm going to write an example, and then we'll talk about it and play with it and do a bunch of variations. But rather than sort of talk through it initially, I'm just going to write out a whole example, and then we'll have something to talk about. So I'm going to make a function called getSecrets. Remember, str is the type of strings. So this function expects a parameter which is a string, and then it's going to return a string. And I'm going to say if message equals, here are all the secrets. Else, message equals, no secrets for you. Return message. Okay. So, hopefully it should be obvious what the intention of this is. And again, we'll talk through all the specific syntax and what all these pieces are, but hopefully the idea of this is clear, right? It takes a password as a parameter, and then it checks if the password is lemur, which is supposed to be like the correct password. And if it is, then the message is going to be, here are all the secrets, and otherwise, the message will be no secrets for you. So we can try, once it loads, we can try it out down here. Get secrets. So if I give it a string like, hello, or I'll say open sesame, that is not the correct password. And if I run it, it says no secrets for you. But if I give it the correct password, then it says, here are all the secrets. Okay? Is this big enough? Yeah? A little bit bigger? Okay. Cool. Is that good? All right. I'm using a different browser, and so it wasn't like, didn't have the same zoom that I had done before, so I wasn't sure. Okay, so a few things about this. So in general, what is this? That's weird. So in general, we say if, and then we have some condition, and then a colon, stuff, and then else stuff. So this is like, it's a little more, going to be more general than this, but so we have so if is a keyword, right? Just like other keywords we've seen so far, like def and return. So it has a special meaning to Python. So we say if, and then we put some kind of condition. We'll talk in a minute about what that could be. And then we have a colon. So the colon is required, just like the colon at the end that we saw at the end of def, right? And then you can put some stuff in here. And then you could have else with another colon and some stuff. And so, actually, maybe let me, stuff one, stuff two. So I'll say stuff one, so if the condition is true, it will do stuff one. If condition, make little bullet points. If condition is false, actually, let me be even more specific. It will do stuff one and skip stuff two. If condition is false, it will skip stuff one and do stuff two, okay? So when you have an if, well, in particular when you have an if-else, then it's only going to do one of these things, right? It's going to choose which one to do based on the condition. It's never going to do both of those things. It's going to do one and skip the other. Okay? So let's talk about, so what could the condition be? The answer is the condition can be anything that will eventually give us a Boolean value, a true or false value. So anything that will result in a bool that is a true or a false. For example, what kinds of things could result in a true or false value? It could be some kind of comparison. So for example, x less than 5. So you could say if x less than 5, and so on. It could be a more complex, I'll say combined expression. E.g., you know, x less than 5 and, you know, 7 equals 9, or, you know, p is less than or equal to z. Right, because we learned all these ways using and or, not, to be able to combine different Boolean expressions to give us one big Boolean, right? And you can look at this and you can see this looks very similar to stuff that we tried last class, where if we kind of evaluated that whole thing, eventually we would get down to just a single true or false. And so we could use that as, anyone think of what else might we be able to use that would give us a true or false value? Just curious if anyone has other ideas.
If this is odd or this is even.
Yeah, we don't know how to do that yet, but once we do, yes. But that will also be a kind of like comparison. I mean, what are things that we've seen so far that we could use that would give us that could give us a Boolean?
True, false.
Yeah, I mean, so we could literally write true or false. Although that's not that useful, because if you're writing, you know, if true, then why bother writing the if? It's always going to do that because it's true. No. So we could have a variable that contains a bool. I don't think we've seen an example of that, but we'll see lots of examples. You can put anything you want in a variable. It doesn't have to be a number. It could be a true or false. We could use a function that returns a bool. You could call a function, you could say if, and then call some function. The function's going to do what it does, and then return a true or false, and then if can use that. Okay, we'll see examples of all those things eventually. But. Okay, you do not need to memorize this list. That's not the point. The point is you can use anything. Anything at all that will give you a true or false can be used in an if. Okay, and this is really important because I don't know if I mentioned this before or not. I think I have, but right, it's this idea of compositionality, that we can build up more complex programs by putting together simple pieces in kind of unlimited ways, right? So we're not restricted in terms of like, oh well, here you can only use this kind of thing, and here you can. It's like there's a bunch of things, and as long as you use something that gives you a true or false, you can use it in an if. You're not restricted. Okay. All right. So now let's just do a bunch more examples. So I want to show you a few variations of this. So one thing is, in this example, I don't necessarily actually need this this variable called message. So here's another way I could do the same thing. I'll call this get secrets 2. So this works as well. On the lab, I think all the examples you saw were functions that they did some stuff and then they had a single return at the end, right? There doesn't necessarily have to be only a single return at the end, especially when there's some conditionals involved, because so what return actually does is, as soon as Python sees return, it immediately stops the function and just gives that as the output. So even if there's more stuff after that, as soon as it hits the return, it's going to stop and return that value. Okay. In this case, it doesn't really matter because it's only going to do one of these anyway because of the if, right? So it's like, all right, if password, it checks if password is equal to lemur. Let's say that's true, so then it does this part. And then it just says, okay, we're just supposed to stop the function and return. So that's what it does, right? Or if it's false, it's going to go here, and it's like, we should stop the function and return this. So this will do the same thing. No secrets for you. We could even, so it turns out the else, this else part is not necessary. So you do not have to have that. So this actually works as well. So let me talk through what this is going to do. So, oh, I should give it a different name. So first, it says, all right, you give me your password. First thing it does is it's going to figure out if this is true or false. If it's true, then it says, okay, since this is true, I am going to do whatever's inside this if. And the thing inside this if says to return. So it just stops the function immediately and returns that as the answer. It never even looks at this. Because as soon as it does this return, it's just, all right, this function's done. This is the answer. If this condition is false, then it doesn't do whatever's inside this if. It skips it. And then it goes on to the next thing. And this is the next thing in the function after the if. And so it's like, all right, I'm going to do this now. Right, so it only gets to do that last return if when the if is false. So secretly there. That works. Sucks. No secret. It works. Okay. What questions do you have so far?
Can't we use like print instead of return?
We'll talk about print later, but it's not necessary right now because we're just
Yeah,
trying things out at the.
And there is return. I mean, you say that when it says return, it just stops there. Then why does it go to the next return? And I mean, how does it work? Like.
Wait, sorry, say that again? So.
I mean, there is return, and you say behind Python says there is return. It stops the code here. It says return. So you wrote return in the next line as well. So why does it go to the next line instead of the first one? I mean, it should have stopped there.
So if this is, it's a good question. So if this is false, if this condition is false, that means it's not going to do whatever is inside the if. Right? If it's false, it says, okay, we should not do this. We're going to skip it. And so then it just skips this, and then it goes on to, right, the next thing after the if would be this return. Does that answer your question? Yeah. So I guess I should say, right, that so we're starting to see like the indentation matters a lot, right? How does it know that this is the next thing it should go to? Well, because this return here is lined up with the if. If we moved it over like this would be very different. Why is this different? This is different because now, since these are both indented, they are both inside the if.
So it skips over both.
So in this case, it would skip, if this was false, it would then skip both of these,
You wouldn't get it.
and it would just be done. It wouldn't return anything. Does that make sense? So how Python knows, like, well, let's do another example where we have more than, because you don't have to have just one line inside of if. You could have multiple lines. And how does it know which lines go inside the if? It's the ones that are all indented. And then as soon as you have something that's not indented, it's like, all right, that's the end of that if. This is the next thing. Yeah, Aaron.
So if it's past the, so go like that.
Yep.
Like if it was the second return, if it was one indent higher, it would skip over that as well. Like anything
You mean like over here?
more
Or
to the right.
even like that?
Yeah, it would skip over that.
Well, this is a syntax error because there's nothing, like you can't just like arbitrarily indent stuff extra, right? But if you had, maybe we could have another if in here, right? That like, in this case, like if this if was false, it would skip all of this stuff because it's all, yeah, I mean, you're right. Even though this is like indented more, but it's inside of this if, which itself is like lined up here, which is inside of this if. So it's just like kind of nested, stuff can be nested inside of it.
Yeah, sure.
Yeah, good question though.
I had another
Yeah.
question.
Mhm.
So, like, you indented it, so it means that you don't need to write else. Python will understand that there's another condition because you didn't like put it in the same line. So, like, you can do it like we can skip the if, then Python will understand that this is if and this is else.
You mean if I just leave this out?
Yes.
No. Well, Python, if you don't say if, then it's not an if. It would just do both. Well, in this case, it wouldn't do both because as soon as it did the first one, it would stop. No, and like there's not, so Python is not magically figuring out that this means else. That's not what's happening here, right? In this case, the reason that, because if this is true, then it does this return, which means that it immediately stops and never even gets to this last line, right? That's kind of why this works. But it's not like this is inside of an else. This is just another separate thing after the if. That's not inside of an if at all. I don't know, maybe we're making this overcomplicated. Let's do some more examples. All right. I'm just going to do an example. X int, return int. We're going to say if x is less than 10. I'm kind of making up a random example here, and then we'll make sure that we understand what it's going to do. If x is less than 10, then we're going to say x is assigned 10, else x is assigned x plus 1, and then we're going to say x x is assigned 2 times x, return x. Okay, how about this? So I'll talk through a couple things first, and then I'll give you like some sample inputs and see if you can work with someone next to you and figure out what it's going to return. So, right, we have an if and an else. These go together. And so notice, because this line here is not indented, right? This line is not part of the if. So this is just the next thing that happens after it's done this if. And I've kind of emphasized that by leaving a blank line here. Python doesn't care about the blank line. But, right, so in particular, if I were to indent this, that would be very different. Now, this line is part of this else, and this line will now only happen if Python decides to do what's inside this else, right? But if I put it here, it means that this line is going to happen no matter what. First, it's going to decide whether to do the if or the else, and then once it's done that, then it'll come down and do this line afterwards. Okay. The other thing that maybe you haven't seen that might seem a little weird, right, is that I'm using x. And I know a few of you figured this out or did it on the lab. Because like in an algebra, in a math class, this doesn't make any sense, right? X equals x plus 1 just has no solution, right? But remember, that's not what equals means in Python. Equals in Python is not like doing an algebraic equation. It's saying, okay, first we're going to figure out the value of the thing on the right-hand side. Once we know what value that is, we will then put that value into a variable. So this means first look up what value x has and do that plus 1. Once you figure out what that number is, now take that number and put it into x. So there's no problem with this, right? This just means take whatever value x had and make x 1 bigger than what it was before. And this is a really, really common thing that we'll see a lot, where you have some variable and you just want to change it, make it bigger, do something to it. And so you can just like use the previous value and then assign it a new value. Okay, so this would increase x by 1. This would just like take whatever was in x and double it. Okay. Any other questions about what this means before I, yeah, me?
So in the like third line, how you put it this after a like blank line.
This
So
one?
Is it,
Oh.
yeah. Is it like else if like another condition? Like if the above doesn't work, then this one will work?
This part you mean?
Yes.
No, this is not part of a condition at all. This line will happen no matter what.
I mean like it will just work either if or else, then work on the last line.
Right, so it'll choose to do either this one or this one. It'll do one of these two and not the other one, right? And then once it's done that, then it will come to the next thing, which is this, and it will always do
And
this.
Is this compulsory? Like it will do it must.
It'll, say that again?
I mean like Python will like run that last line compulsory. Is it like?
Yes, yep. It will definitely run this line. So the first thing it does is do this whole if.
Yes.
The next line is this, and so it does the lines in order, right? Okay, so let's say 5. So I'll give you a minute or so. Work with someone next to you. Find some or one or two people next to you, and just work through. You can either write it down on paper or just do it in your head. Right? What is this gonna? When I hit enter, what's gonna get printed out? What is this function gonna return? When we give it 5.
Is it less than 10?
That's if x is greater than
That's still less than outside. So I'm confused on how that x equals 10. When you're trying to make that 5 equal 10. So I'm not actually
Yeah,
I got it. So if in this case the number is less than 10, right? I assume the 5, that's 5 equals, it'll be 5 equals 10. Or are you just trying to make it equal 10?
No, this means take whatever value is on the right and put it into the variable on the left. So for this, when you do this line, it doesn't matter what value x had before. It just replaces it with a new value.
So it would be 10.
Right. It would just make it 10, yeah.
So, okay. That could,
Yeah, no, that's a good question.
anything less than 10 automatically equals to anything higher than it would jump. That makes a lot more sense. Okay. That makes a lot more sense.
All right, what do you think?
It's gonna be 20.
Okay,
20.
we have 20, another 20. Any other guesses or confirmations? What was that, 20? 20. It is indeed 20. Congratulations. Yeah. So again, just to be clear, right? So x. In this case, I called the example function with an input of 5. So x is going to be 5. So if x less than 10, well, x is 5, so 5 less than 10 would be true. And so that means it is going to do this part, and it's not going to do this part. Right? So it will do this, which means, okay, forget about the 5, x is now 10. And then it's going to come down here and do this line, which just doubles whatever is in the variable x. So it was 10, so now it's going to be 20, and then it returns that. Okay? All right, what about this? What about if I had put 12 as input?
Oh, you're always. You're always. Yep, I'm on the same page.
So
It will never stay
So 12 is just
average case. Probably going to be divided because major. That's what I'm starting to say. Some people I think I'm going to take. I think I need. I think I gotta take sassy. Since it's
that's the parent on that bad.
All right,
that's not bad.
so what do you think?
26.
26?
I'll take it.
Yes, it is 26. All right, so x is 12, so this time, this condition is false. 12 is not less than 10. So that means it skips this part, and it goes and does whatever's inside the else. So it will do this, which will take the previous value of x and add 1 to it. So now, x was 12, so now it'll be 13. And then, as always, it will finally come and do this line, which will double it, so it'll be 26. Okay, good. All right, I'm going to do another example. So I'm going to do an example involving random numbers. So I'm just going to show you how we can generate random numbers with Python. So we've seen import math, right, which gives us a whole bunch of functions to do stuff with math. There's another library called random, which gives us different functions for generating random numbers, or random, actually not just numbers. You can like pick random things from a list, or once we learn about those, there's lots of different things. But for now, the important things that we have, so we're going to use, so random.random. It's like, why do you write it twice? Well, the first one, you always have to write random dot, because we imported that, just like we had to write like math dot, whatever, right? And then the random library has a function called random. So this will always give us a random float between 0 and 1. Okay? And then there's also something called rand_int, where you give it like a low and a high. And so this will always generate a random int between, whatever low and high you give it. And I think it actually, I honestly don't remember if it includes both endpoints or if it includes one and not the other or something, but we could look it up in the documentation if we want. So okay, it definitely includes the bottom endpoint. If I run it a bunch, 9, 10, okay, it got to, so it includes both endpoints, all right. But it's just gonna be a random integer in that range. Okay, so what I want to do is I'm going to make a function called raffle. And this function is interesting because I'm not giving it any parameters. Okay, because this function, what it's going to do, it's just going to generate a random number and then use that random number to decide what it's going to return. So we don't have to actually give it any information to start with. It's just going to pick its own random number, right? So we're going to say, we'll call it r is random dot. Let's just do, I'm just going to do random.random. And then we can kind of, based on, like if we want a 10% chance to win a certain thing, we could just check if r is less than 0.1. And that would give us kind of a 10% chance, right? So for now, let's just say if r is, let's say we have a 10% chance of winning nothing. So we'll just say like return, wow, so unlucky. Better luck next time. Else, for now, I'm gonna extend it later, but we'll just say return, you win a stick of gum. Okay, so we can try this. Okay, of course, as expected, I want a stick of gum. Oh look, all right, I already got unlucky. Stick of gum. All right, so are we sure it's random? Because I've run it 4 times and I've gotten unlucky half of it. It was supposed to be only 10% of the time. No, you can't tell with random numbers. Like it.
Back. Wow. You're getting lucky. You're getting lucky.
Yeah, I'm getting luckily unlucky. All right. No, I mean, I fully believe you can take my word for it, or you can try it out yourself. If we ran it like 1,000 times, it would be approximately 10% of the time, but It just so happened the first few times we ran it, we got very unlucky, and anyway, but, all right. So, I want to now say, all right, let's say we also have a, you know, so if r is less than 0.1, then that just means, all right, that's a 10% chance of not winning anything. So in the else, I now want to have like multiple different prizes you could win, not just a stick of gum all the time. Okay, so I actually am going to put another if inside this else, right? Because basically I'm saying, first I want to check this, ask this question, is r less than 0.1? And if it's not, then I have more questions that I want to ask. Okay, so in the case that it was false, I'm now going to ask another question and have an if. Did you have your hand up? Or?
I was just going to ask, would you also put another, I mean, you also put another else in there as well?
Oh, we can, yeah. Again, you don't always have to have an else for every if, but you could, and so probably we will. So let's say, you know, if r is less than 0.2, turn you win a car. Else, and I have to indent that, okay. I could actually ask, you know, if r is between 0.1 and 0.2, but actually if we get to this else, the only way we'll get inside this else is if r was not less than 0.1. So at that point we already know that it's at least 0.1 or bigger. And so we can just ask, okay, well, is it less than 0.2? That'll give us another 10% chance to win a car. So we can try this out. We want to stick a gum. Stick a gum. Gum. Come on. Want a car. Oh, unlucky. Come on. Lucky. Give me a car.
This is gambling.
Yeah. Just one more. Okay, no, just one more. Just one more. Seriously. Like, I'm starting to be like, did I do something wrong? Like, is it? No, I'm pretty sure I did it right. I mean, it's telling me I want a stick of gum, so it's definitely getting. It has to do this if in order to even get to that. All right. Yeah. All right. Woohoo. All right. It's rigged. It's rigged. No. You know, we could put other things in here, right? We could be like, all right, else, you know, if r is less than, you know, 0.5, you know, return you win a, what should we win?
A house.
Oh, a house, wow.
Let's go gambling.
All right. You know, if r is less than 1.8, what did you say, Maddie? A yacht. Wow. All right, let's try it. Rerun this.
Let's go gambling.
Yeah!
All right. Okay, we can stop now. Yeah, right.
And this is how we all gain.
Oh, back to it.
All right.
Keep going now.
All right.
I feel like I'm in a casino right now.
Yeah, exactly. Okay. Okay, cool. Any questions about how this works? So notice, right? I mean, whoops. How do I do that? So just like, you know, we said, okay, what can go in the condition? And I said it could be anything. Anything that will give you true or false, right? Likewise, what can go inside of an if or inside of an else? Anything, right? Including other ifs or functions or right, like anything you can write in Python, you can put in there, and we'll see examples where that makes sense. Now, this kind of sucks though because this looks really ugly, and like as we add more and more conditions, right, it's like going way off the edge of the screen. And okay, this right. You can imagine, like, here we have, what, 4 different conditions, but you could imagine a scenario where you might have, like, 20 conditions or something, and that would be, like, by the time you got to the 20th condition, it would be, like, way over here. Okay, so that's terrible. So, because this is such a common thing to do, where you don't just have, like normally an if gives you two options, right? It's like either this is true or this is false. But there's tons of examples in the real world where we don't have two options, we have, you know, a bunch of options. Like here, right, where there's like 5 different prizes we could win, and we have to ask a series of questions to figure out which one it is. This is so common that Python gives us some nice special notation for doing this in a way that doesn't suck as much, okay? So, I will show you what it is, and then we will, let's see. The above works, but it looks really bad and is annoying to write. Python gives us special notation just for this. So here it is. So I'll call this raffle 2. And in particular, specifically, it's special notation for when we have an else that immediately has an if inside of it. Because this is a super common thing that you're like, okay, ask a question. If it's true, here's what to do. But if it's not true, then what we immediately want to do is ask another question. So what we can do is we combine the else and the if into a single keyword called elif. Okay? There's really nothing magical about it. Elif really is just an abbreviation for else and then an if inside of it. But because it's just this abbreviation, we don't have to keep indenting stuff every time. So all these else ifs I can replace with elif. Oops.
So you will have to type elif every single time then?
Yes.
Okay.
You do have to type elif every single time, but you don't have to keep indenting them more every time, right? So elif is just another keyword that Python gives us. And we don't need it in the sense that we could just do else and then have a nested if. This is just kind of for convenience. Right? I hope you agree that that looks much nicer. And it's much more obvious what's going on. It's just like you have a series of questions that you ask. But I do want to emphasize, right, this entire thing, like if, elif, 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 else, that's all part of the same if statement. And so kind of Python considers this whole thing as a group, and it goes through these questions one by one. It picks the first one that's where it's true, and it does that, and then it skips the rest. Right, so it's going to do exactly one of these things. You know, if this is true, then it's going to do this, and then it just will not consider any of the rest of these. Right, because notionally they're all nested inside of an else, and so it would skip that if it was true. Okay, so Python will go through these conditions one at a time and pick the first one that is true, then skip the rest. Okay? I'm going to show you something else. I want you to tell me how it's different. Or what do you think? So, do you think this will do the same thing, or will it do something different? And if it will do something different, what do you think it does? Yeah, Wally.
Since it's all if, it's going to read all of them up until the else. So as long as it's less than 0.1, it'll be applicable to everything.
Exactly. Since every time we say if, we're starting a brand new separate if. Right? So, like I said, the previous one, since every time we said elif, it was like connecting it back to the previous thing. And so Python kind of considers it all as part of the same thing. But here, it's just like, okay, well, here's an if, and then here is a separate, completely unrelated if, and then here's a separate, completely unrelated if, and then this if and this else go together, right? But so, yeah, what Wally was saying is like, well, what if r is, 0.05? Well, first it's going to do this. This is true, so it's going to, okay, actually, I guess because we have return, I should have said, so, because we're doing return, in this particular special case, because we're doing return, it actually does the same thing as the previous one, which was not my intention. Because as soon as it hits a return, it just stops the whole function and returns that, right? But imagine that we instead said like, you know, prize. If we made a variable like this, okay, you know what, never mind. Because this is also going to,
That would also.
well, this just does something weird because let's say r is 0.05, it's gonna, like this is gonna be true, so it's gonna set prize equal to this. And then it's done with this if, so it goes on and does this one. And then it's like, all right, let's check this condition. Oh, that's true too. So now let's overwrite the prize and make it a different string, right? So we'll kind of, I think we'll always win a yacht, basically. Because, well, or a stick of gum. Because anything less than 0.8, it's going to keep overwriting prize until it gets to here, and then it's going to set it to that. So it's not going to work properly. Which is a little hard to tell, but basically we're going to win way more yachts than we should.
I'm set for life.
Yeah. I think we have enough yachts for everyone in the class to have one at this point.
I'm set.
Exactly.
Yeah.
Exactly. Yeah, a spoiler alert though, it costs a lot of money to have a yacht. Sorry.
You can get an extra like $250,000 to fail.
Exactly. Yeah, exactly. Just the tax on the yacht is going to be. All right. Okay. Let's not worry about this too much. I can't show you a great example of this yet because like kind of all we know how to do is do return or like set a variable in the. But anyway, the point is like if you have a bunch of conditions that are all kind of part of the same group of choices, like you wanted to choose one of them, then you should always use elif, like if, elif, elif. Don't just do a bunch of ifs like this because it's going to do all of them instead of just one. That was the point. All right, any last questions? All right, have fun in lab. See ya. Or no, wait, what day is it? It is Wednesday, yeah. See, have fun in lab. Exactly. All right. Suddenly I was like, wait, is it Monday? Yeah, I'll see y'all.
Made like a.
What was that?
She made like another elif and at like 8 points, less than 8 points. Like
Oh,
very
right,
small,
right.
very
Like a
small,
teeny, right, yeah.
very small chance, and you like give you like a crazy prize.
Win a space station or something.
Yeah.
I don't know, like what would be better than all these prizes we already have?
Casino house, yacht,